Alright, boys and girls, today's lesson is lesson 7-6, compare fractions with unlike denominators. We've been working with unlike denominators a lot lately when finding equivalent fractions. So we're either using multiplication or we're using division. For example, if I have 3/4 and I want to find two different equivalent fractions, I could multiply it by 2 over 2, gives me 6/8, or I can multiply it by 3 over 3, give me 9/12. And then the other way is if we have 9/12 and we're trying to find equivalent fractions using division, we could divide each by 3 to give us 3/4. These are just different ways of finding equivalent fractions. So if we want to know which was greater than or equal to, actually all these would be equivalent fractions to each other. But if we need to find out which is greater of the two, we could use different methods, and those methods are what I'm going to go over with in today's lesson. So, all right, turn to the first page, page 245. And the first way to compare fractions is by using fraction strips and number lines. The thing is, in most cases, when you're trying to compare fractions, you're not going to have a number line or a fraction strip in front of you, but you can always draw them yourself. I know in small group I've noticed a lot of you drawing the fraction strips. Not a whole lot of you draw the number lines, but they're very similar to each other. These two are very similar to each other in the order of, in a fraction strip they put the fraction in the middle of it, and then a number line is almost like a tape measure. They put it on the actual spot to tell you that's how far you have until you get to that certain fraction. So it says use number line to compare the fractions 4/5 and 7/10. Okay, well, if you look, 4/5 is here, 7/10 is here. So if you compare the two, you would say 4/5 is greater than 7/10, because 4/5 goes further on the line than 7/10 does. So if you were to cut a pizza into 5 pieces and get 4, and cut another pizza the same size into 10 pieces and take 7, you're actually getting more pizza with 4/5. All right. Next one here, we have used. It says use of fraction strips to compare the fractions 3/4 and 5/6. So here, in the case of fraction strips, they're in unit fractions. So you have to kind of count them in your head: 1/4, 2/4, 3/4. So 3/4 stops right here. That would be where 3/4 would stop. And the other one is 5/6. So we have 1/6, 2/6, 3/6, 4/6, 5/6. 5/6 stops right here. So if you had to compare the two, you would say that 3/4 is less than 5/6. And then you can go on and answer 3 through 8 by looking at the fraction strips or the number lines. So you can do that when the lesson's over. Go back and finish those. So let's turn to the next page. You can compare fractions by using common denominators. I'm going to go over this page. This is the most important thing in the lesson in my mind, because this is the part that, as an adult, this is what I use. I don't use number lines or fraction strips when I'm trying to compare fractions now in my head. I use common denominators, and that's the easiest way for me to say, okay, that one's bigger. Simple as that. So this page is the most important page, I want to say, in the entire unit, all of Unit 7. This is one page where you should kind of put it in your head and hopefully put it in there and it stays there forever. Alright, so it says you can compare two fractions with different denominators by writing equivalent fractions that use the same unit fraction. The fractions will have a common denominator. You can use different strategies to do this. The ones shown below depend on how the denominators of the two fractions are related. Alright, so in the first case, if one denominator is a factor of the other, okay, notice the two fractions we're using are 5 and 10. Well, 5 is actually a fraction, is a factor of 10. So when that happens, what you would do is you would keep 5, 10 the same, and then you would think about, how does 5 become 10? How does 5 become 10? Well, 5 becomes 10 by multiplying by 2. So in this case, you're going to multiply each by 2. So that gives you 6 on the top for numerator and 10 on the bottom for denominator. Now that you know, you've made each of them 10, and you didn't have to change. You didn't have to change to 5/10 because now they equal the same. What you did is you took 3/5 and just found an equivalent fraction to it that had the denominator of 10. And now you know that 6/10 is bigger than 5/10. So go back to the original equation, the original question, and it actually means 3/5 is bigger than 5/10. That's the first case. The next case, the only number that is a factor of both denominators is 1. So in this case, 5/8 and 4/5. Okay, to get 5, you get 1 times 5. And to get 8, you get 1 times 5. I'm putting all the factors 1, 2, 4, and 8. And the only equivalent factors, the only factors they have are the same, are 1. Remember, when it comes to 1, we don't really deal with 1. So here's something you can do. You can take the two denominators of 8 and 5 and multiply them to get 40. And now what you can do is you can make each fraction have 40 as the denominator. Okay? And this is something we'll go over heavily in small group. So what you could do is you could take your 5/8 and make 8 become 40 by multiplying by 5. Therefore, you have to multiply the numerator by 5. So then it gives you 25/40ths. You also have to do that to 4/5. How does 5 become 40? Well, it multiplies by 8. So you have to do the numerator by 8. That gives you 32/40. Now, when it's all said and done, you should be able to figure out that 25/40ths is smaller than 32/40. So, in the big picture, 5/8 is smaller than 4/5. Okay? A lot of content in this lesson. A lot of content on this page. Okay, this is stuff that you will need to know. It's okay, because I'm not going to throw it at you and boom, we're done and go to the next one. Okay? We'll spend some time on this. So there is a number besides 1 that is a factor of both denominators. Okay? So there's a number besides 1 that's a factor of both denominators. Okay? In this case, 8 and 12. Okay? 24 is the common multiple of 8 and 12. So we're going to use 24 as the denominator. In this case, rather than take 8 and multiply it by 12, we're going to take 12 and double it to get 24, and 8 times 3 is 24. So this case, what you're doing, you're trying to find something that they both can go into. Okay? That is a factor of both the denominators. Very similar to the one above, where you just multiply the two, and you really can just multiply the two every single time. But in this case, you'll get 96. And there's actually a smaller one that works, and that smaller denominator would be 24. So 24 is a common denominator because 8 times 3 is 24 and 12 times 2 is 24. So what you're going to want to do is you're going to want to take your 5/8. How does 8 become 24? Well, you multiply it by 3. So you multiply the numerator by 3. Gives you 15/24. Take your 7/12. How does 12 become 24? You multiply by 2. Therefore, you need to multiply the numerator by 2. If you do that, you get 14/24. Now you have the same denominator on each, and the numerators are different. This way you can tell that 15/24 is bigger than 14/24. Therefore, your original question of 5/8 and 7/12 shows that 5/8 is larger than 7/12. Once again, this is stuff we're going to go over in small group. So, using some of those strategies we use, I'm going to do a couple of these down here, and then I'm going to have you do the rest when you're done with the lesson. So we get 3/5 and 2/3, which is bigger. Well, they don't share a factor, so what I'm going to do is I'm going to multiply 5 by 3 to get 15. Okay? Therefore, I need to make 3/5 turn into 15. I might as well do it down here. 3/5 turn into 15. So how does 5 become 15? Well, you multiply by 3. Therefore, you multiply the numerator by 3 to give you 9/15. 2/3 needs to become 15 as the denominator. So how does 3 become 15? Well, you multiply by 5. Therefore, you need to multiply the numerator by 5 to give you 10. So now your answer is 10/15 or 9/15. So this tells you that 2/3 is just a tad bigger than 3/5. Alright, so I'm going to get rid of, that was not what I want to do. So I'm going to get rid of stuff here on the bottom. I'll just do this. And we'll do number 10. 10/12 and 5/6. Well, if you look, 6 can go into 12. So we're going to keep 10/12 the way it is, but we're going to make 5/6 into a fraction that has a numerator or denominator of 12. How does 6 become 12? Multiply it by 2. So therefore you must multiply the numerator by 2 to give you 10/12. Okay, if you look at this, 10/12 and 10/12, that means the two fractions are equal to each other. And I'm going to do one more for you. Darn it. I'm going to do number 11. 3/4 and 8/10. Here's one that you could do 4 times 10 to give you 40, but there's a smaller denominator that they each have in common, and that would be 20, because we know 4 can go into 20 and 5 and 10 can go into 20. So 3/4 needs to turn into something over 20, and 8/10 needs to turn into something over 20. So how does 4 become 20? Well, you multiply it by 5. Therefore, you multiply the numerator by 5 to give you 15/20. How does 10 become 20? That's an easy one. You multiply by 2. Therefore, you multiply the numerator by 2 to give you 16/20. And if you look at this, 16/20 is just a tad bigger than 15/20. So 8/10 is greater than 3/4. All right, so those are just a few different strategies. I actually absolutely love this page, and this is something I think I might want to myself just kind of copy and hang in the room, because that is this page right here will be a page that, like I said, you're going to need to know for a long time, because this page is extremely important for your understanding of fractions. So I guess if you have any time to work on some unfinished workbook pages, if not, small groups are going to be a whole lot about this.